So here I've continued my wishful thinking and I've written out the complete grammar. I think I've got it right. And now all I'm missing is something that understands this format. So let's continue the wishful thinking and wish that we had a function that could take this format and turn it into something that we can then use in a parser. So here I'm applied the wishful thinking, say I wish I had this function grammar that would give me this grammar G, and then I could use it to parse expressions. And now it's up to me to deliver on that promise or that wishful thinking. So the first thing I should ask myself is, what do I want this object G to look like? One good idea would that G could be a dictionary. And the keys of the dictionary would be these things on the left-hand side, and then the values of each key would be some object corresponding to this representation on the right-hand side. I would have expression, something like this. And now all I got to do is figure out what goes on the right-hand side. Here I've made a choice, and what I've said is, well, the right-hand side looks like it's always going to be a set of alternatives. The order matters, so I'm not going to make it into a set. I'm going to make it into a sequence of some kind. And let's make that a tuple. So the right-hand side is always going to be a tuple of alternatives. It might be a tuple of length 1, but it's always going to be a tuple. Each element of that tuple is going to be a sequence. Here, a sequence of 3 items. Here, a sequence of 1 item. We'll represent sequences as lists. So here, it's the 3 items, and here's the 1 item. So every right-hand side is a tuple of lists where the lists are a sequence, and each element of the list is an atom. And the atoms can either be the name of a category that's defined on the left-hand side, or they can be a regular expression that's going to match an actual characters in the input when we go to parse. Now, of course, I could have typed in the whole grammar like this to begin with, but that would have been messy and error-prone and harder to read. So I did myself a favor imagining the language I wanted and writing in that language, then figuring out how to get it into something the computer can understand. And now all I have to do is write this function grammar that translates from this format into this format. And fortunately, it's really easy to write this function. And here the whole thing is. Here's what I've done. I've initialized the grammar that I'm going to produce to be the empty dictionary, and then I've gone through the whole description. The description is the input, and split it up by lines. For each line, I've split up each line by the arrow into left-hand side and a right-hand side. And then for each right-hand side, I've split that up using the or sign into a list of alternatives of 1 or more. And then I've just said, let's assign to the left-hand side, expression or term, a tuple, because that's what we're using for alternatives, of the map of splitting up each alternative. So the alternative here would be a string. It would be the string, everything starting from term, ending with expression. And then I just mapped the split function to it to split it up into individual atoms. That would split it up into a 3-element list, term, plus or minus, and expression. And that's all I need. This is a description of the grammar format, immediately implements it, and builds up a dictionary for us. And I should say, I've used here this utility function split. It's just like string.split, except when it splits things up, it strips the white space from each of the pieces.